Okay, so just wanted to thank Eleanor Rose for sending me an email asking me about the assignment. Grab the assignment up here. Here we go. So she was asking how to approach the assignment, and so it's obviously on chance. So you need to think about what we learnt about in the chance section of term 1. So anything to do with volume, surface area, circle theorems aren't applicable to this assignment. Only what we did on probability, which was towards the end of the term. So you asked to do a written report, and we are focusing on target games. So games such as darts, games such as archery. Darts and archery. So you need to make sure it's planned out, and you are asked to design a new game. So obviously you will not be just taking a dartboard or an archery target, you'll be making your own. Okay, so we're giving you a set amount of criteria. So you need to have 4 scoring zones. So if you think about what we learnt about the different kinds of outcomes, you'll need to consider that. You can make these of any shape, but if you have a target, you need to make sure you consider the fraction of the overall target that each scoring zone has, whether it's, say, for example, 50% of the board, 1% of the board, whatever. You need to do that as a fraction. You need to have 3 throws, so you need to have 3 events, and you need to be calculating the probability of these 3 events. Now, whether these are independent, dependent is up to you. So you need to set a particular score to win. Okay, so 4 scoring zones, 3 throws, and you need to set up a score that you need to win. Okay, and here's the crux of it. You need to make sure that the chance of you winning is less than 5%. So you have 4 scoring zones. You are determining the fraction of the overall shape, and you have 3 throws. Okay, so if you're looking at this, you need to calculate the probability of getting this score, and that score is going to be made up by what you get by making 3 throws. You determine what the scoring zones are, so you determine whether a score is worth 100 points, 50 points, 20 points, 10 points, whatever. But you also determine what the fraction of the overall shape is. So if you think you're throwing randomly at the board, the fraction of the board that the zone takes up will determine the probability of hitting it. Okay? So, it's due on the 1st of May. Okay, so you need to list your assumptions, you need to list the steps you need to complete the task. So going through your idea of making this game. Any technology that you need, whether it be calculator, Excel, Word, whatever. So here you are creating your target game and you're calculating probabilities, and we'll get back to that. Actually, we'll do that now. So this is the PowerPoint that we used when we started on probability. So the probability of an event occurring is the number of ways an event can occur divided by the possible number of outcomes. So you need to consider that in regards to your target and exactly what you are asking. So you want your probability of winning to be less than 5%. So for some of you, you may be using compound probability, so the probability of A and B occurring. Alright, so do remember that you have 3 separate throws. Consider whether your events are mutually exclusive or not. So if they're mutually exclusive, they cannot occur at the same time. For example, a roll of a dice, you can't roll a 6 and a 1 with the same dice in the same throw. That's the example that we used. Do consider whether you are using independent or dependent events. Okay, and I will be putting this PowerPoint up on eLearn in the same place, or in Term 1 section. Okay, so if a previous event affects the probability of an event occurring now, those events are dependent. For example, drawing cards out. If you leave the card out, then obviously the probability changes. Or rolling of dice are obviously independent. Conditional probability, so that if a probability of event A is different, if B has already occurred, you need to consider this. And complementary events. Okay, so complementary events. So probability of rolling a 6 is 1 in 6. Probability of rolling a 6 is 1 in 6. So the probability of rolling not a 6 is 1 minus 1/6, or 5/6. So that is what we learned about with probability, and you need to be applying this to a game that you are making with this information. Okay, so the best piece of advice I can give you is when you are going through your assignment, go through the ISMG, okay, and give yourself a mark. So go through your formulate section and see which of these dot points applies to you. If you have each of these 3, you get 4 out of 4. If you have one of these and one of these, you get either a 3 or a 2, depending on how well you did. If you don't have any ticks in here, and basically you don't satisfy any of the descriptors, you get a 0 out of 4. Same applies for the solve, same applies for the evaluate, same applies for the communication. So, best advice I can give you is this is the important information. Consider what you learnt about in probability and what you've learnt about in probability in previous years. On final piece, I would recommend using CK12, and I will include a link here. Where are we? Here we go. CK12, Basic Probability and Statistics Concepts. And it's basically an online interactive textbook. I will be including this link in eLearn. Going through that, going through the PowerPoint, using your understanding of what we have done is the best thing that you can do for approaching this assignment.